say here we have Vx, the voltage given right here across this resistor, and also here we have a voltage dependent voltage source, that is 4Vx. Now let's try to solve for the current passing through this. Here we can assign any direction, like we can say current is going through clockwise or counterclockwise, doesn't matter, because if you assume clockwise and if it's wrong, you're going to get the negative answer. It means the current is passing through the opposite direction, so you're not going to get the wrong answer. So let's see how you can solve this. So first, what you can do is you can write the voltage in terms of V is Ohm's law. If you apply Ohm's law right here, V is equal to I times R, and here we have Vx, and you can see the current is going through negative to positive, so we put minus. R is 30, and current is given by small I. The current is going to be same everywhere since it's in series, so that's why I. Okay, now let's apply Kirchhoff's current law here. Actually, Kirchhoff's voltage law. Kirchhoff's voltage law says that addition of all the voltage in a loop is equal to 0. Now let's go and add the voltages and see if we can solve any of this. So like we can solve for Vx or I. Both, any of them will be helpful. So if we are taking like minus to plus, we put negative 30 voltage. This is not a voltage, this is ohm. The resistor here, the voltage here is minus 30i. So if it's minus 30i, then minus to plus, that's going to change this one to plus 30i. Okay, and then we have what? We have 12 voltage, that's also going from minus to plus, so that's going to be plus 12 voltage. And here, if the current passing through this is plus, this is minus. So this, again, here we apply Ohm's law, that is I times R. R is 8 ohm, this is 7 ohm. So 8 times I, and that's going to be negative because it's going from plus to minus. You know, sometimes you see if it goes from plus to minus, they put a negative, they put a positive, and sometimes they put if it's going from minus to plus positive. So it doesn't matter actually, because if you keep up with the sign, that's okay. Like here, the reason I am putting plus to minus is negative because there's going to be a voltage drop. Like whenever the current passes through resistor, there's going to be a voltage drop. That's why I put a negative. But you see some people, they put like if the current pass through positive, they put plus. If current pass through negative, they put a minus. And both gonna work out, because at the end, when you solve and find the, like when you solve for it, it's gonna actually work out. So it doesn't matter. But you had to just keep up with that. Like if going through minus to plus is positive, you had to keep that everywhere. If you put like that's the thing. Like you had to keep the same thing everywhere. And if you put minus to plus is plus, then you have to put plus to minus a minus. That's all you have to be careful about. So here, plus to minus again. So that's is minus 7i. And then here we have plus to minus. So that's going to be a minus 4Vx. Okay, that's the whole thing is equal to 0. So here we have two unknown variables. We have I and the Vx, and we already know Vx is equal to minus 30i by applying the Ohm's law right here. So instead of Vx, I can write 30i. That will make this one unknown variable. Now let's go and do this. So 30i plus 12, and I can combine these two. Minus 8 minus 7, that's minus 15i, and then minus 4 times minus 30i, that's equal to 0. So 30i, and let's say actually add all the i's together. Let's multiply this one first. So 30i plus 12 minus 15i. This is minus 4 times minus 30, that's plus 120 I, that's equal to 0. 120 plus 30, this is 30i. 120 plus 30, that is 150. 150 minus 15, that is 135. So 135i is equivalent to minus 12. Okay, so 135 is equal to minus 12, then I is going to be what? I is, let me double check if I'm doing right. So first we have this one minus to plus. Okay, minus to plus 30i. Minus to plus 12 voltage, and plus to minus, that is minus 8i, and then plus to minus 7i, and then plus to minus is minus 4 Vx, that's equal to 0. 30i plus 12 minus 8 minus 7, that is minus 15i, and then here we have minus 4, and instead of Vx we plugged minus 30i, and here we have 30i again, plus 12 minus 15i, minus minus became plus 120i. Okay, 120i minus 15, that is 105. 105 plus 30, 135. Okay. Here we have minus 8i, minus 7i, minus 4vx. Then we have plus 12. You know what? This is actually made it complicated. Let me keep it as Vx, okay? Let me keep this term as Vx because we already have it in voltage. First, keep that one. Vx is positive. Let's keep that one. Yeah, that's the problem. Like, better to put this one right here and then do the conversion because I neglected a negative sign by confusing with this. Okay, let's erase the whole 30i. Okay, so let me rewrite. So Vx plus 12, this is the voltage here, Vx, and that's positive because the current is going from minus to plus. So I put a positive right here. And if you solve for Vx using Ohm's law, that is minus 30I, right? Because there's a voltage drop. Yeah, minus 30I. So now we have to plug this minus 30I right here. This is actually a minus. Okay, so here we have minus 30I. Then this will become minus 45, 120 minus 45. So that's going to give us minus 75, positive 75I. So I is going to be negative 12 divided by negative 12 divided by 75, and that is negative 0.16 ampere. So this negative actually represents, our assumption is wrong, like this is not actually going through clockwise. This the direction of the current is actually counterclockwise. If we take counterclockwise, it's going to be positive current. It's actually going this way, and the current is 0.16 ampere. Okay, so that's what we figure out from here. If it's negative, it means our assumption is wrong and it's in the opposite direction. And so we have found out the current. Now we can solve for the voltage by plugging in this equation. Vx is negative 30 times negative 0.16, and if you multiply and calculate this one, you're gonna get 4.8 voltage. So this voltage right here is 4.8 voltage. If this voltage is 4.8, then this is 4 times of that, 4 times 4.8, and that is equivalent to 19.2 voltage. Okay, now we have solved for the current and the voltages. That's basically it. And if you can also find the power across the voltages and resistors. Now let's try to find the power. Okay, I'm gonna actually erase this one and find out all the powers. So let's say if the question asks you to find power, let's start with power at this 12 voltage. P is P 12 voltage, and we know that power equation is given by, let me use a different color. Power equation is given by P is equal to VI, or P is equal to I square R, or P is equal to V square, like P is equal to VI. And if you apply Ohm's law is what? I times R. So that's going to become I square R. Or you can apply Ohm's law in different way, like V is equal to IR. Therefore, I is equal to V divided by R. And if you substitute I, this one, that's going to give you V square over R. E is equal to V square over R. So we have three equations for the power. But for this one, which one is better? We have voltage and the current. So VI is better. VI, 12 voltage, and the current is passing from negative to positive. So that's going to be a power supplied, actually power absorbed. If it's negative to positive, that's power absorbed. So that's going to be positive. And the value of the current is 0.16. And if you calculate, you're going to get 1.92 watts. And this is absorbed. And we can calculate power across this 30 ohm resistor. For this one also, it's going from minus to plus. The current goes through minus to plus. So this is going to be a power absorbed as well. For this one, which equation is better? We know the voltage. We found out the voltage, and we know the current. We can apply that one. Voltage is what? 4.8 voltage. 4.8 times current, that is 0.16, and that's equivalent to 0.768 watts power absorbed. And if you take for this 8 ohm resistor, the current is going from plus to minus, so this is going to be a power applied because it's going to be negative. So negative, for the 8 ohm resistor, we know the current, we know the resistor, so we can use I square R. I square is 0.16 square, and then R is 8 ohm, and if you calculate this value, that's going to give you negative negative 0.2048 watts. And power at 7 ohm resistor, again we can use the same equation, I square times R. So 0.16 square times R is 7 ohm, and if you calculate this one, you're gonna get negative okay, wait a minute, 7 ohm resistor plus to minus, right? So yeah, negative with this power supplied. Yeah, so this is like, if you calculate this one, this is negative 0.13, actually 1792 watts. This one is supplied, supplied, and for the 4Vx voltage here is also going from positive, the current going from positive to negative, so this is going to be a power supplied. Let's put a diamond shape for it. Which equation we can use? We know the voltage and we know the current, so VI, so 19.2 times the current, that is, let's put a negative here, 19.2 times the current, that's 0.16, and that's going to give us negative 3.072, and this is supplied. And that's basically it. That's all we need to know. That's it for this video. Thanks for watching. Don't forget to subscribe my channel. See you guys on the next video.